So, students, today we are going to start this topic, electromagnetism. The name itself, you can see the name itself. So, electricity and magnetism, both are combined, and combinedly we study electricity and magnetism. So, we have the concepts of electricity and magnetism separately in the lower classes. So you know what is meant by electric charge, how many types of charges are there, what are the properties of electric charges, Coulomb's law, electric field, electric flux, Gauss theorem in electricity, everything was related to electricity. And we have two types of electricities, static electricity, current electricity. We know that static electricity deals with the charges which are at rest, they are not in motion. They produce electric field, and we calculate intensity of the electric field using Gauss theorem, integral form and differential form also. And we calculate electric field for different shapes, conductors like sphere, cylinder, a line, infinite line, like that. And what about the current electricity? So the current is the flow of charges from one point to another point. That is from positive terminal to negative terminal of the battery. If a conductor is connected to the battery, so we can take a conductor. So conductor, this is the conductor, a long conductor. I will connect this conductor to a battery. So when I connect this to the battery, then from positive terminal of the battery, this is the positive terminal of the battery, and this is the negative terminal of the battery. So we always represent the negative terminal with a short line and a positive terminal with large line. So this is a conductor. So this is the positive terminal. So we'll write a plus, and this is a negative terminal of the battery. So if you connect this conductor, this is the long conductor here. So this we'll write it as A, this end, and this end is B. We'll write like this. So this AB conductor is connected to the battery between two terminals here. So once you connect this one and current flows, instead of a current, I can say the charges. What are the charges here? Electrons. We know that the conductor has free electrons on the surface even at the room temperature. So this is the conductor. On this surface, free electrons are there. Free electrons means the electrons which come out from the orbit, which are free from the nucleus, which are not bounded with the nucleus, and move randomly on the surface of this conductor. So this is a conductor. So when you, until you connect this conductor to a battery, there is no flow of charges. Charges are in random motion in the absence of this battery. Here, this is the battery, what we connect here. If your battery is not connected here, then all the electrons, free electrons, they randomly move on the surface of the conductor. Now, we have connected a battery between the two ends of the conductor. Once you connect this battery, as electrons are negatively charged particles, I repeat, the electrons are negatively charged particles, they carry the negative charge. Once they carry the negative charge, they are repelled by, here this is negative conductor, they are repelled by the negative conductor. So they flow towards the positive conductor. Remember, this is flow of electrons. So this is flow of electrons from negative terminal to positive terminal. So I will write like this. This is flow of electrons from negative terminal to positive conductor. So an energy, an electrical energy, which flows through the conductor in opposite direction. That is, it is in anti-clockwise direction in this picture. So then an energy, so this is the direction of that energy which is flowing through the conductor. which is called current. We denote that with I. So this is the current flowing through the conductor due to the flow of free electrons from negative terminal to positive terminal. From positive terminal towards the negative terminal, current flows through this one. So we have current electricity which is flowing from positive terminal to negative terminal between the two ends of the conductor here. So we have two types of electricity. One, static electricity. Two, current electricity. Static electricity does not flow, just charges settle on the conductor, surface of the conductor. And whereas this current electricity is produced and it flows from one end to the other end of the conductor due to the flow of electrons from negative terminal to positive terminal. Okay, so this is about electricity. Somebody is doing that. So this is about electricity. So this flow of electrons produce current electricity through the conductor. Okay, so electricity, current electricity is a form of energy which is due to flow of electrons. Now, coming to magnetism. Magnetism is also a form of energy which is produced due to the dipole arrangement of the atoms within the substance. We know that a magnet attracts some substances which are called magnetic substances, and it attracts the opposite pole. Opposite poles are attracted by each other and similar poles are repelled by each other, and we can calculate the magnetic force, magnetic induction, magnetic flux, everything here. So we study magnetism and electricity separately in the lower classes from 10th or intermediate or 12th class. Now, this chapter, this concept, it is a combination of electricity and magnetism. So this experimenter, oersted, so he first discovered that electricity and magnetism are not separate topics, separate concepts. Both are related to each other. Both are related topics here. It means electricity produces the magnetism. He discovered that electricity current flowing through the conductor produces magnetism. If you take a magnet, so I will take a bar magnet. So this is the bar magnet here. And we have a north pole. For every magnet has a north pole and a south pole here. So these two poles are at the edges. So these two poles here, they have some pole strength, and pole strength is maximum at the edges, poles, end points, and at the center, this is the center. At the center of the bar magnet, magnetic strength is almost zero. So if you take a magnet, around this magnet, you will have a magnetic field. So around this magnet, you will have a magnetic field where this magnet or any of these two poles can attract or repel the magnetic substance or any other magnet. If you keep another magnet here, any magnetic pole, so small pole here. So I will keep a small pole here. So when you keep a small pole, that is, if it is a north pole, then it is attracted by south. If it is a south pole, it is attracted by north, like this. So if you keep a small magnetic needle, it moves freely within this magnetic field. So within this magnetic field, the magnet has its influence, its strength. It attracts or repel another pole and attracts magnetic substances here. So, and some other substances are there which are repelled by magnetic pole. I will tell you later. So this is a magnetic field. And if you take a conductor, a long conductor, this is the long conductor, and this long conductor, and if you, I mean, give the charge to this one, remove the electrons or give some excess of electrons like this here, then it will have its electric field here like this. It will have the electric field. So this is the electric field which is produced by the electrons, charged particles. If charged particles are electrons, excess electrons are there. In this conductor, if it has extra electrons than its atomic number, suppose if atomic number is 10 or 11, then 11 electrons and 11 protons are there. If it gains more than 11, it will have negative charge, or if it loses some electrons, 2 or 3, it has positive charge, but this charge will not flow. So we can have the electric flux in electric field, and we can calculate magnetic flux in the magnetic field. And what about this electromagnetism? This electromagnetism, which was the first experiment done by oersted, it proves that this electricity and magnetism are related to each other. They are combined topics. They are not separate topics. Now we are going to study what is the oersted experiment and what does it explain about electricity and magnetism. Here, now I am going to explain oersted experiment here. For that, I will take a long conductor. So I will take a long conductor. This is the long conductor here. Now, I will connect this conductor to a battery, and so I will represent one end of the conductor with A and another end is with B, like this. I will connect this conductor to a battery like this here, what we have discussed earlier, and then current flows through this conductor. I will represent the conductor for meanwhile with from left to right. Suppose this is from left to right. Current is flowing through this conductor. So this is the current flowing through the conductor here. So as the electrons are flowing from B to A, electrons are flowing through this conductor from B to A. So this is the reason why the current is flowing through this conductor from A to B, here, from left to right. Meanwhile, for currently, I am representing this and from left to right. So this is clockwise direction here. So we know that flow of electrons produces current, and around this electric field is developed here. And what about oersted experiment? What does it explain here? Oersted discovered that, so along with this current electricity, it produces magnetic field. Magnetic field is produced around this conductor. So we don't have any magnet here. We are not placing any magnet. We are not placing any magnetic substance. Nothing is here. Just we are passing the current through this conductor. Then how do you say that magnetic field is produced? What is the proof for that? How can you explain that magnetic field is produced due to the current passing through the conductor? We have to prove that. For that, so first we have to, we should study the main property of a magnet here. For that, let us take the Earth's geographical directions here. So this is the Earth's geographical direction. So we can write like this here on the surface of the Earth. So this is the North Pole. So this is North Pole, and this is South Pole, East and West here. So North and South, the line joining the North Pole and South Pole, this line is the geographical line here. Earth is rotating from west to east. The direction of the rotation of the earth is west to east. That is the reason why the sun rises in the east. So the earth rotates with a high speed, and the elements, the materials, the metal substances, many metal substances are available in the core of the earth, inside the surface of the earth. But as you go deep inside the surface of the earth, then temperature of the earth increases, even the pressure also increases. Due to high pressure and temperature, all the materials are available in a molten state, that is liquid state. That liquid also rotates from west to east along with the earth. So earth gets the magnetic property, and we will have the two poles of the earth's magnet. Here this is the two poles of the earth's magnet here. I will draw like this here. So this is the two poles of the earth magnet, and this is called meridian, magnetic meridian here. This is north pole and this is south pole. See, listen. So here we have two. One is geographical line, which is represented with a red color, red line, and the blue line indicates the magnetic meridian line, the earth line, that is line joining the poles of the earth, magnetic poles of the earth, north and south. If you observe the two lines, they have the opposite poles. That is, the geographical north coincides with the south magnet, and south geographical line coincides with north here. So if you suspend, if you take or any magnet, bar magnet or a small magnet, and you have the magnetic needle also, we have drawn the magnetic line support in the lower classes, which is just like a small needle. So it is like this here. This is the magnetic needle. So it has an arrow mark here. This arrow mark always represent north pole. This is the north pole here. And we have a U shape here. It will have like this here. It will have, this is the south pole here. And if you take this north pole, so this is the north pole of the needle, and this is the south pole of the needle. If you suspend a small magnet, it always lies towards north south of the geographical line. It means it always lies towards south of the earth magnet and north of the earth magnet. It always shows north and south. If you take a bar magnet, suspend the bar magnet, it always shows north and south of the geographical line here. If this same magnetic needle, I will keep here. So I will keep the same magnetic needle here in this magnetic field. So we have the bar magnet here. This is the bar magnet which has the magnetic field, and I will keep the same magnetic needle here placed. But there are two magnetic fields. One, this is the external magnet due to bar magnet and Earth's magnetic field. So the two magnetic fields interact with each other, and a force is acting on this small magnet. It is deflected. It means it shows the direction. North pole moves towards the south. So in the absence of any other external magnetic field, this magnet always shows north and south. If you keep the same magnet, if you place the same magnet in an external magnetic field, it is deflected. So north pole is deflected towards the south here. So when it is deflected, we must observe that a magnetic needle deflects in the external magnetic field. If it is outside, if there is no any external magnetic field, it always shows north and south of the direction of the earth here. Remember, you have to remember the 2 points. One, in the absence of any external field, the magnetic needle always shows north-south of the geographical line. If you keep this magnetic needle in the external field, then it is deflected. So the deflection is observed only in the external magnetic field. Now, coming to the oersted experiment, this experiment. So an amount of current is I is flowing through this conductor A and B. Oersted, he discovered that magnetic force, magnetic field is developed around this conductor. So we have shown the magnetic field also. Now we have to prove that there is a magnetic field around this conductor. For that we have to place this magnetic field, needle here. So I will place this magnetic needle here. It shows or it is deflected. So it is deflected like this. So if you don't pass the current and battery is disconnected, then there is no deflection. It always straight, always shows north and south of the geographical line of the earth. But if you pass the current, it is deflected. See, when current is passed, the magnetic needle is deflected. The blue line indicates the deflection. If there is no current in this conductor, the magnetic needle does not deflect. The red line shows zero deflection without the magnetic field when no current is passing through that. Now, coming to the next point is, if you reverse the direction of the current, if the current is reversed, that is, we are now passing the current from left to right, clockwise direction. Now, meanwhile, I will change the direction of the current here. So when I change the direction of the current here, from again here, I will right to left. So this is the current. In the second case, right to left. So direction of the current is reversed. According to oersted experiment, current is reversed, magnetic field also reversed. That is the magnetic field. Suppose this is the north pole, and here we have the north pole at the point A and south pole at the point B. In the first case, when the current flowing through the conductor is from left to right, clockwise direction. Now the current is reversed. Reversed means the current is flowing from B to A, that is from right to left. Then the magnetic poles are reversed. Here at point A we will have south, at point B we will have north. Obviously, this needle is deflected towards this direction. So in opposite direction. So even in the changing the direction of the current also, in both cases, there is a deflection in the magnetic needle. Magnetic needle shows the deflection. Magnetic needle showing the deflection means there is a magnetic field around the conductor. So we can conclude that, so the current passing through a conductor produces magnetic field. So current and magnetic field, electric field and current, magnetic field, both are connected to each other. So this is about the oersted experiment. Oersted proved that current flowing through the conductor produces magnetic field.